Okay, so now we are going to learn something about powers. As you have there written, the power of a number shows you how many times to use the number in a multiplication. It is written as a small number to the right and above the base number. Another name for power is index or exponent. The exponent of a number says how many times to use the number in a multiplication. For example, 5 to the power 3 equal to 5 multiplied by 5 and multiplied by 5 3 times equal to 125. Here in this power you can see the base and the exponent. Base is 5 and the exponent is 3, and as you can read there, 3 is the number of times that you have to multiply the base. How many times you have to multiply? 3 times. 3 times you have to multiply 5 because the exponent is 3 and the base is 5. Okay, and what about if the exponent is 1 or 0? Okay, here we could have problems, but there is an agreement about that. And if the exponent is 1, then you just have the number itself. For example, 9 to the power 1 is 9, or 5 to the power 1 is 5, or any number to the power 1 is that number. And in the case the exponent is 0, if the exponent is 0, then you get 1. For example, 9 to the power 0 is equal to 1, or 5 to the power 0 equal to 1. But now we are going to learn some other properties. Let's see, and the first property, if the power has the same exponent. For example, 6 to the power 3 multiplied by 3 to the power 3, and that's equal to when the exponent is the same, like in this case, you have to multiply bases. 6 multiplied by 3 is 18, and you have to keep the same power, 18 to the power 3. And the same for division. 6 to the power 3 divided by 3 to the power 3 is equal to, let's see that the exponent is the same, so you have to divide bases. Here you have to multiply bases, and here you have to divide because there is a division. So 6 divided by 3 equal to 2, and you have to keep the exponent. So the result is 2 to the power 3. And we could solve this power because it's very easy. 2 to the power 3 is 2 multiplied by 2 and multiplied by 2 3 times, and is equal to 8. In that case it's a bit more difficult, but it's very easy too. What about if the base is the same? For example, if we have 6 to the power 2 multiplied by 6 to the power 3, in that case you have to sum the exponents, and you have to keep the base. So the base in the result is 6, and the exponent is 2 plus 3 equal to 5. So 6 to the power 5. If you multiply 6 to the power 2 multiplied by 6 to the power 3. And what happens that it's very easy, because if you think 6 to the power 2 is 6 multiplied by 6, and 6 to the power 3 is 6 multiplied by 6 multiplied by 6 3 times. So in total 6 to the power 5. And what about division? Well, with an example we are going to understand very good. This property is it's very easy to, if you divide, for example, 6 to the power 5 divided by 6 to the power 3, for example, to divide when the base is the same. In that case the base is 6 in both cases, and the exponent is 5 in that case and 3 in that case. So the result is the same base, and the exponent is the subtraction of these two exponents. 5 minus 3 is 2, so the result is 6 to the power 2. So here there are one property divided into two properties, and one property divided into 2, because one property is for multiplication and another for division, and here the same, one for multiplication, to multiply, and to divide. And what about the other property? The other property means that when you have, for example, 2 to the power 2 and to the power 3 double power, you have to multiply the exponents. So the result is 2, you have to keep the base, and to multiply the exponents. 2 multiplied by 3 is equal to 6. Don't forget, it's not 2 to the power 5. It's not the sum of 2, it's not the addition of these two exponents. It's the multiplication. You have to multiply these two exponents, right? So don't forget, you have to multiply. And finally, could you do that activities? Well, that's very easy. Let's do it. For example, in that case, the first case, let's see that the exponent is the same. In that case we have to do first the brackets. So in this bracket we have, I'm going to change color, we have these two powers with the same exponent. So the result is you have to multiply bases. 3 multiplied by 5 is 15 to the power 2. Okay, you have to keep the exponent. Multiply by 15 to the power 2. The result is, now we have the same base, so you have to keep the base and to sum exponent. 2 plus 2 is 4. So that's a result as an only power, with only one power. In the second case, let's do first numerator and later denominator. Don't think it's a fraction. Think that's a division. That's a division, because we have this divided by x to the power 5. Okay, the numerator we have 2x to the power 5 and x to the power 4. So the base is the same, so we have to sum exponents. 5 plus 4 equals 9, and this 9, that's a 9, and this to the power 2, and here x to the power 5 equal to, what do we have to do when when there is a double power? Well, we have to multiply. So x to the power 9 multiplied by 2 is 18, and here is 5. But that's, I told you before, is a division. X to the power 18 divided by x to the power 5. So the result is, when the base is the same, to divide, you have to subtract exponents. So the result is x to the power 18 minus 5 is 13. So x to the power 13 is the result. Okay, now third example, third activity, we have 2 to the power 3 multiplied by 3 to the power 2. If we have a look to the properties, let's have a look to the properties. We can't find a property with that characteristic. So what do we have to do? We have to do the operations as we learned, as we know. So first we have to do the powers. 2 to the power 3 is 2 multiplied by 2 multiplied by 2 3 times, and it's equal to 8. So 2 to the power 3 is 8, and 3 to the power 2 is 3 multiplied by 3, so that's equal to 9. And now you have to multiply these two natural numbers, and the result is 8 multiplied by 9 is 72. So that's the result. We can't use any one of the other properties we learned before. And for the last activity, for the last case, is the same. It's the same, because we have we have an addition now, an addition. So it's impossible to use the other properties, because in the other properties always appeared multiplication or division. So now we only have an addition. So we have to find this number. 2 to the power 3 is 8, and plus 3 to the power 2 is 9, and the result is 8 plus 9 is 17. So that's the result, 17. We can't use in that two cases no property, no one of the properties before, without the properties, because the hypothesis is not that we had before. So that's a result. We have to do the operations as we learned before.